So today's agenda is very much focused on the fact that we've seen cameras now being used as a sensor capability, and now that we're starting to use them, we're starting to see that rather than stream the information back to a central source and process it, the plan is very much to put intelligence on the front end of that. And that's really what the four speakers are going to talk about this morning. So we speakers both from both companies and universities, really giving us insights into work that they've been specifically doing about incorporating AI into vision systems.
All right. Hello, everyone. My name is Sebastian. I'm one of the co-founders of Atari. I'm mainly a software engineer, and in the last few years, I have gotten familiar with deep neural networks and AI in general. And today I'm joined by Aling, who will represent herself.
Hi, this is Aling Wu. I am AI and IoT Alliance Director in Aling. Aling is a company focused on embedded computing platform. So, of course, we have a lot of AI edge compute products. Then here you see the brand up is we also focus on help developers to start their AI development quick. So we have quite many development kits around. So I think with today's presentation, Sebastian and I is going to share with you how we work together as AI software development and hardware platform provider.
Exactly. Thank you, Aling. So today's talk will be all about how do you get AI models really production ready and use them in your vision systems. So I don't have the controls at the bottom, but I will try my keys. Okay, right now I think I can't advance to the next slide. Now, okay, I can see the arrows now.
Yeah, sometimes a little bit sort of slow, so if you just wait.
I clicked once, I will wait.
Yeah.
Okay, maybe a second time, let's see. Okay, now it works. Great. Okay, I want to start by showing you what are we doing with AI at Atari. So real world applications here to get you, give you an idea of what AI is really capable of. So for example, in this picture, you see that Atari is doing surface measurement here together with a wood company. And we measure how big the logs are, for example. And of course, if you're doing surface measurement, then surface inspection is not very far off. So here we are analyzing logs, how much of the bark is still on there. That's important for our clients for various reasons. And we can do that today with AI. But of course, there are different or other use cases as well. So in general, in quality control, there are a lot of different applications. You could say, for example, the alignment of different parts. As you can see here in the green box, it points upwards, that's correct, but this one here is not correct. Or there are missing pills, for example, in your packaging. Stuff like that can be easily done today. But there are many more of them. So there are more than we could even imagine, and daily we learn from our customers new approaches or use cases for AI. And here you see some stuff that we have been doing in the past. So from license recognition over to detecting whether construction workers carry all their safety equipment, to blood analysis in the medical field, and also with the recent COVID, we also trained a model to detect masks. This is everything here you see is possible. So, as I already said, a lot of people have great ideas how they could use maybe AI to accelerate or improve their vision systems. But once they actually want to deploy them into a production scale, they face a lot of issues. A few of these problems can be summarized under software. So you have this high entry barrier where you need specialized people in order to work with AI. How do you solve the training? How do you train the model, especially if you have to retrain over time? How do you keep that in a production scale? Then, of course, always the question of the inference. Then there are so many different frameworks out there. And do you want to execute and inference the AI model on the cloud, or do you prefer it on the edge? And of course, you should never forget the security and data privacy and the long-term support updates for that. Because if you leave the system unattended for too long, it might become susceptible to hacker attacks, for example. And then we have the other category of hardware problems. So vision systems, of course, you need some image sensors, but which one do you choose? Does it have a global shutter or rolling shutter, for example? How many FPS? What is the quality? If you decide, for example, for an edge application, then of course there are certain limitations of the hardware you can use. You can't use the biggest GPUs, for example, in every device. Then we have different AI accelerators from different vendors. We have housing requirements even. I mean, this is something that you maybe don't think about when we just talk about AI, but when we are talking about real production use of AI, this is something you have to consider. How do you integrate with other systems, for example? So there's some industry standards here that you need to consider. And what if you want to control some other analog things such as robots or, for example, step motors, stuff like that. So you see there's a lot that you have to take care of. And we at Atari, we developed one end-to-end ecosystem that allows our customers to basically don't have to worry about any of these issues. They come to us with a vision and we provide them with a ready-to-use solution. Our ecosystem is split into 3 parts. And today I only want to talk about the 2 on the right side, nGin and nCam, because these are the parts that focus on inference. The left-hand side, nLab, is then mainly for training. So today it's mainly about the Atari nCam. nCam stands for neural camera, and it's our in-house developed neural smart camera. It comes with an x86 architecture, and it is equipped with up to 3 AI accelerators. These are Myriad X VPUs from Intel. This makes this camera probably the highest performance currently available on the market for edge inferencing. We have an open architecture with our nGin component, which I will explain later on. And as mentioned, for example, if you have certain housing requirements, we have an industrial housing available that is certified up to IP67. We have integrated LEDs into the camera and also a motorized lens. That means you can almost control anything of the camera remotely. You don't have to access the camera all the time physically. The camera is also equipped with 12 GPIO connectors, and these are not the standard GPIO connectors because you can draw up to 2 amperes over them at a maximum. This makes it really powerful connectors that you can use to, for example, control robotic arms or any other kind of step motors, for example. This whole camera is manufactured in Germany, and we are using certain hardware components. For example, the accelerator chip or the CPU board is from our partner in Aling, which will Aling tell you later more about. Okay, so this is basically the nCam. It's a powerful smart camera, but you always, of course, need some kind of interface for it. So we created the nCam Vision. This is the UI interface for the camera, and it allows you to remotely control the camera. So for once, of course, you want to see the image stream or the video stream of the camera. You can also upload and execute your own models, which I will tell you later more about, and write custom scripts for it. nCam Vision is nice because it's cross-platform, so you can even run it on, for example, Android tablets or Windows desktop, for example. Vision also allows you to, as I said, control the camera. On the right-hand side in this picture here, you can see, for example, that you have the possibility to select between different stream codecs, or you can control the lens, as I said, or switch on the LED and configure some strobe lighting. But also all the driver values that the image sensor you are using offer you can be accessed over the nCam Vision UI. So this is an example of how you would upload your AI model. We support different frameworks, first and foremost, of course, ONNX, because that's a nice format, standardized across different frameworks, and we can load that. But also we support natively TensorFlow, Caffe, Darknet, and all the models from the Intel or Model Optimizer. But so I presented to you now nCam, and it's a very nice hardware platform, but hardware is of no real use if you don't match it with some nice software. And that's why we created nGin, which is our smart neural engine for edge and cloud devices. And it's basically a machine vision SDK. We incorporated into nGin two main parts. One is that we can run with its traditional image algorithms. So if you come from a background where you haven't used much AI in your image processing, you will find the same functionality in nGin as well. But on the other hand, we will be handling all of the AI inference in nGin. The key of nGin is that it supports various hardware backends. So whether you use it in the cloud, for example, with GPUs and NVIDIA, or you use it on the edge, as we prefer to do it with, for example, CPU or specialized VPUs or even FPGAs, as we have seen already today, you can load the model into nGin, and nGin will take care of converting the model to the right format and using the optimized version for the different backends. We have also, of course, support for all the industrial cameras that are out there. So on the left side here, you can see different vendors or standards that we support. And nGin makes it very easy that you can simply connect the video stream and it does everything else for you. The last thing I want to point out about nGin now is its capability to be scripted via a very easy scripting language that we created, and it's called our nGin scripting language. It's a dynamic scripting language, and you can. It's really performant, so it matches Python and sometimes surpasses it, and it runs on a Go backend. It is executed on the nCam itself, so we have real edge processing here. Everything, the video stream analysis, the inferencing, the decoding and encoding of video streams that you export out of the camera, for example, it's all done on the edge inside the camera. There's no connection needed for to a cloud or something like that. And you can control with the nGin script the whole camera pipeline. So how do you want your frames to be converted before you put them into the AI model, for example, or which AI model or models do you want to load? How do you want them to execute after each other? This can all be done by the nGin script. You can manage your AI models and customize the result API. And this leads to a really minimized network traffic because you only push out the results, not a whole video stream that needs to be analyzed, for example, in the cloud. On the right-hand side, we just wanted to show a short example of a script. Here you can see that we import an nGin module and we load two AI models after each other. One is a detection model, the other is a classification model. We define one endpoint to publish our results. It's an API, for example, HTTP JSON, very simple, can be made interoperable with almost any software. And we have a throttler where you could, for example, say, okay, I don't want to analyze all the 60 frames that come from my image sensor, but I only want 30 because that's enough for my use case. And then there's not much more code needed. So we have under 40 lines, we define the whole pipeline where if we get a frame, we simply check our throttler if we are allowed to execute or process the frame. We put it into the detection model. Once the detection model here in the next on result handler is finished and we check the result was okay, we can, for example, put it into the classifier with the frame. And then the last thing is the same again, just that we check the result again and may publish it or may not. So this is really a really simple script, but it does really powerful things in the background, loading these models, and you don't have to worry about which exact chip are you using right now or which underlying hardware is mainly used. So as the nGin script itself is really running on the camera, we created another SDK that allows you to now develop, for example, third-party applications running on different systems. I presented to you already the nCam Vision UI. This would be on this side here, and it uses the nCam SDK already and builds a UI out of it. So if you, for example, wanted to build your own UI to your nCam, you could use the SDK and do that right away. Or you want to write your end-user application that just uses the nCam results and builds other stuff around it, a third-party application. Both of this is possible with the nCam SDK. We provide native support for C, C++, C#, Go, and Python. The communication is encrypted by default, and we have very efficient result pushing, so it's no polling mechanism, of course, to keep the network traffic low. The camera is automatically discovered already in the SDK. That means once you have plugged the nCam into the network, you should see the camera right ahead. You don't have to search which IP has been assigned to the nCam or something like that. And as I said, you can build your own vision, and vision is meant literally. So if you don't like our UI, you could do your own. This allows you to focus really on the end user application because all of the work is being done inside the SDK. And I just wanted to announce at the end of my talk now that we plan to do an nCam workshop where we dive deeper into the details of what I just presented. And if you are interested, you can always shoot us an email here and we will notify you once this is ready. So as you have seen now, the nCam is, of course, ready to use, and it's a nice product that you can build your own solutions around it. But we wouldn't be there without our partner Aling, who provide us with the hardware components that are actually needed to run the inference on the camera. So it's my pleasure now to hand over to Aling.
Thank you. Thanks to Sebastian. I think Sebastian showed us in the AI model development how it could be sped up. So, but in our experience, what we notice is, especially when Aling, we specialize in edge AI solution. So in edge AI solution, it means you want to spread the device as many as possible in the edge. Then you come to the limitation of the cost, then also of the resource. So I divide the AI development journey into 3 steps. First step is a proof of concept. So you try to see, can your idea can be carried out by AI? Can AI do the job for you? Then some people start to take advantage of, currently there are a lot of development platforms available. Then you try those pre-trained model on your laptop or on the cloud, on your desktop. So where you have quite a lot of resources, then in the cloud you have unlimited resource. But when it comes to edge device, then let's face a fact, we are not going to move a lot of a server to the edge in the working place. So then the edge device selection become very important. Then how can you transfer the great work you have done in the training to the edge inference? So Aling focus on 4 major AI edge inference platform. So here we talk about Intel, NVIDIA, HiSilicon, and Google. Then, so with every different camps, they have their different focus. Yeah, so Intel's, they develop with their 4 major CPU, GPU, VPU, FPGA. Then NVIDIA doing the GPU. Google even invent the terminology TPU. So everybody do on his own. So I think for the users, for the developers, after you finish your model training, then actually your journey just started. So, okay, I have my model work perfectly. Then how can I implement which hardware platform should I select it? Then is it only about should it run on CPU or GPU? Oh, it's even more. Yeah, where is the edge device will be placed? Is the temperature a concern? Is the IP for the waterproof is a concern? Do you need to consider more interface for all the devices you have to connect it, and the sensors which you also want to collect the data so that you make your AI model work more smartly, incrementally? Then also don't forget a lot of things you need to have a connectivity, which is not only Wi-Fi, 4G, Bluetooth, LoRa, 5G, all kinds of things, and how many camera you are going to use. In a lot of application, users, they can live with 1 camera, but in also some applications, they would like to connect as more camera as possible. So I think this is where Aling come into the place to help you to see, okay, based on the model you have trained, then also based on all those requirements we mentioned earlier, what would be the best option? So we have a simple benchmark tables to help everybody. So those benchmarks, you should read it as a comparison instead of an absolute number, because we do those benchmark on a specific AI models. So which just help you to read what kind of a platform in comparison with different platform, how many frames per second in different neural network. Then you should see which neural network you are using today, then on which platform it can perform better. So you can see here we have Intel mobile CPU, we have an Intel GPU, and we have the Intel Movidius VPU. We also have NVIDIA from Jetson Nano, Jetson TX2, even till Xavier. So this will give our users an idea how should they start. They have a very good train model, then which hardware platform should they start it. So in this journey, we'll also guide them once they have a reference about probably which hardware platform more suitable. Then instead of on the hardware platform itself, then with many different VPU module, we design Intel VPU as a module type. So it helps you to, if you already have an existing platform, then you don't need to change to other platform. You can add the VPU module. But if you have some specific I/O concern, you do need to have a spatial IP concern connected with spatial sensors, then there are a range of products from Atom till Xeon for your option. So why we do the VPU approach? Because normally in the approach of a CPU, GPU, so we just do it more, i5 is not enough, let's go to i7, i7 is not enough, let's go to Xeon. Then GPU also all the way going to bigger and bigger. But don't forget that the higher the performance of CPU and GPU, the more thermal you created. Then on the edge, thermal is also something you have concern. With the VPU approach, VPU is designed dedicated only for the AI inference. With this approach, you have a less thermal, but a higher performance. So if we go back to the slide earlier, you can see with the 2 Movidius, you can create it 230 frames per second compared with i7 CPU, which is only 72. So VPU is designed for the inference specifically. So with this approach, we can work across many Intel platforms to have a different I/O interface with the consideration of all the points I mentioned earlier, IP, thermal, and the I/O interface.
And just to warn you, we're getting well on time here, so.
Yeah, sure. Yeah. Then for the NVIDIA camp, we also have many different options. So we have a solution from NVIDIA Nano, TX2, Xavier, so all different interface. So what I try to show you is Aling has quite complete range in case you need to find a right hardware platform with different I/O interface. We are actually quite a recipe for you. But in case you are still in very early stage, you didn't train your model yet, you are in very early stage, try to prove, to start your POC. We also have a campaign together with Watari. With $2,000, we deliver the nCam together with a pre-trained model as your wish according to your application. So you can find this campaign in our website or feel free to shoot me on the LinkedIn. Yeah, so I hope this will give you an idea how we can help you then start together in the AI development. Thank you.
Thank you very much, Aling, and thank you very much, Sebastian, as well. I think, yes, I would sort of be very keen to have a camera. It's definitely very attractive.